So next serial communication is I2C communication and then data transfer, and you also see Raspberry Pi, how to configure Raspberry Pi I2C serial communication. So first I2C, the abbreviation of I2C is inter-integrated circuit. So the basics of I2C is a serial synchronous serial protocol that communicates between two devices. So it is a synchronized serial protocol. So here it uses master slave protocol, which have one master, or you can have many masters and many slaves, whereas SPI has only one master. This SPI we will see later. As of now, I2C is a master slave protocol which can have one master or many masters and many slaves. I2C has two lines. The two lines are SDA and SCL. SDA is serial data line, SCL is serial clock line. So there should be pull up of these two lines by 5 volts connection via resistor. So this sentence we will see it in the diagram in the next slide. So this connection is not compulsory because many of the Arduino devices or any master board have internal pull up available. So by configuring we can make these two lines active high. If it is not available, then you are going to pull up by 5 volts connection via resistor. Next, it is generally used for communication over short distances, and it is also used for low bandwidth communications, but it is an effective communication. So this is the diagram of I2C. I2C consists of two lines like SDA, SCL, data line and then clock line. So here in this line you can have multiple masters and slaves connected. So as you can see, slave master, like this you can connect any number of devices. So as said previously, these two lines can be pulled up by 5 volts. The meaning is here these two lines can be pulled up by 5 volts using via resistor. So with this just two lines you can interface 128 devices. That's why it is also called as two wire interface, TWI protocol. So I2C is also called as TWI protocol. So for these two lines you can interface 128 devices. So the I2C device has 7-bit or 10-bit unique address. So to access these devices, master should address them by 7-bit or 10-bit unique address. So I2C is used in many applications like reading RTC. RTC here is real time clock accessing external EEPRAM memory, and it is also used in sensor modules like gyrometer, magnetometer, etc. So master is the one who is going to initiate data transfer between the two devices, and it also controls the clock manually, and the device being addressed is slave. Initiation is master and the device which is addressed is slave. So here data communication we are learning two different ways here, how master can send data to the slave and how master can read data from the slave. So we are dividing and studying. So first under how master can send data to slave. So here master is the one every time who is going to initiate data transfer by sending start bit as 0. So there can be many devices on the line. As we said, using two lines you can interface 128 devices. So there can be many devices on the line. So the master should know to which device I want to communicate the data. For that you need to, master should send the address of slave. That is the point here. There can be many devices on the line. So master should send the address of slave on the line with respect to clock. So master will send right bit. After sending the address, master wants to send the data to the slave. So for that master sends right bit as 0. Right bit is equal to 0 to slave, and once the slave receives that and identifies, so the master wants to read the data from the slave will give acknowledgement to the master by sending the acknowledgement bit is equal to 0. So once the master receives the acknowledgement, then he can write the data. After writing the data, he can terminate the communication by sending the stop bit. So if you see the diagram like this, the from master to slave data write is been done. Next type is master reads data from the slave. So here again master initiates signaling or communication by start bit is equal to 0, and then address of the slave is forwarded by the master. Then master reads the data by read bit. There we have said write bit. Now here master reads data by read bit is equal to 0. Then slave sends the acknowledgement, that is this is the slave which you want to read the data from. So for that to know, the master to know, slave is sending acknowledgement as 0. That means here what is the meaning of acknowledgement is equal to 0? The slave is ready to send data. So data can be anything by zeros and ones. Here just example 011 011. This is the data the slave wants to send to the master, or master wants to read the data from the slave. That is the meaning when we say acknowledgement is equal to 0 from slave. So once the communication is completed, master will give acknowledgement to the slave. Acknowledgement is equal to 1. So when master is giving acknowledgement, we say acknowledgement is equal to 1. But when slave is giving acknowledgement, we say acknowledgement is equal to 0. So this point to be remembered. So next, last, master will terminate the connection by giving start bit is equal to 0. So this is the diagram related to that explanation. So next, Raspberry Pi I2C, how you are going to configure the I2C serial communication. Raspberry Pi has Broadcom processor having Broadcom serial controller BSC. So which is a master fast mode, that is 400 kb by S, and BSC controller. The BSC bus is compliant with the Philips I2C bus. So there are some misunderstanding or unsatisfaction of BSC compared to the Philips I2C bus. So it supports both 7-bit or 10-bit addressing. So it also has BSC2 master, which is dedicatedly used with HDMI interface and should not be accessed by the user. In the same way, I2C bus or interface is used to communicate with the external devices like RTC. Then MPU 6050, magnetometer, etc. with only 2 lines you can communicate. We can connect more devices using I2C interface if their addresses are different. Here whatever we have learned in the previous slides, like how the master to read the data or master to write the data to the slave, the same thing this slide explains in stepwise. So if you get a question on this, you can write these steps. So that was the detailed explanation. Steps of I2C data transmission. So the master sends the start condition to every connected slave by switching the SDA line from a high voltage level to low voltage level before switching the SEL line from high to low. Second step is the master sends each slave a 7-bit or 10-bit of data of the slave, and it wants to communicate with it along with the read or write bit. If you want to read it, it will send read bit. If you want to write it, then it will use write bit. Next step is each slave compares the address sent from the master with its own address. So if the address matches with the slave returns an acknowledgement bit by pulling the SDA line low for 1 bit. If the address from the master does not match with the slave's own address, then SDA line is high. So these steps are in general format. So fourth step is the master sends or receives the data frame. So that data frame is appearing like this, like high low. This is the meaning of the data, like 010101. That is the data we are sending from one device to another device. Next step is after each data frame has been transferred, the receiving device returns another acknowledgement bit to the sender to acknowledge successful receipt of the frame. Next, to stop the data transmission, the master sends a stop condition to the slave by switching SCL high before switching SDA low. So here we are talking data transmission in a general format. So this is the message structure or message format. So start bit, 7 bits or 10 bits of address frame, and then you have a read or write bit. Next you have acknowledgement. Next data bit, which is of 8 bits. After that you can also have an acknowledgement bit, next data bit, next acknowledgement bit. Like that you can transmission the data. Once you complete the transmission of data, communication is end, then you are going to represent by stop bit. So this is again the same explanation here. Master to slave data write. So this master want to write data from the slave using these two lines SDA SCL. So every time the master will start the communication using the start bit. So start bit is equal to 0. After this he should also send the address of the slave to which he want to write the data. After that the data is been sent. After sending the data you are saying write bit is equal to 0. So the master is saying write bit is equal to 0. So this data he want to write it on the slave in the write mode. So once the slave receives the address and checks with its own address, and if it is okay, then acknowledgement bit is equal to 0 is sent by the slave. After that the data can be write on the slave, the 8-bit data. After completion acknowledgement bit is equal to 0. So after completion of the data the master will give the stop bit as 0. In the same way master to slave data read, here data write, data read, anything the first initiation is given by master itself. So master will initiate by start bit is equal to 0, and then he will send the address of the slave and the data what is to be read from the slave. This is the data of 7 bits, and then here I am telling read bit is equal to 0. You observe here write bit is equal to 0, read bit is equal to 1. And after acknowledgement has given from the slave saying that acknowledgement bit is equal to 0, he can read the data from the slave, the 8-bit data, and then after completion of the reading the slave will send the acknowledgement bit is equal to 0. Sorry, master will send acknowledgement bit is equal to 1. So the things you should remember here is when slave is sending acknowledgement bit is equal to 0, but when master is sending acknowledgement bit will be equal to 1. Next, to access I2C bus in Raspberry Pi, we should make some extra configurations. So Raspberry Pi has I2C pins which are given as follows. In the same way the Raspberry Pi board of GPIO 40 pins, these are the 2 pins, 3rd pin and 5th pin, GPIO 2, GPIO 3, these are SDA line and SCL line on the Raspberry Pi board. So to configure, these are the steps. Before start interfacing I2C device with Raspberry Pi, some prior configuration needs to be done. So first you should enable I2C Raspberry Pi. So to enable that, the command we are using in the terminal is sudo raspi configure. Like this, in the terminal you need to type this command. So next step is select interfacing options. Next step is in interfacing options select I2C, enable I2C. Next step is after enabling, would you like the ARM I2C interface to be enabled? Say yes. Then ARM I2C interface is enabled. Next step is OK. So select yes when it asks to reboot. Now after rebooting Raspberry Pi, we can check user mode I2C by user mode I2C port can be visible by entering the command ls/div/star I2C star. Then Pi will respond with the name of I2C port. So this is the I2C port where you can, if you see this, the configuration has been successful. So above response represents the user mode of I2C interface. So there can be some older versions of Raspberry Pi may respond with I2C 0 user mode port. Thank you.